Hello, everyone, and welcome back to our series of Learning to Code with P5. In this video, we will be talking about previously learned concepts of loops and maps, and we will see how we can combine those two together and where we can use them. So let's get started. Okay, so first things first, make sure that you have remixed your project here and you've given it a name. I've already done so, so I'll just move forward with it. All right, so now let's talk about what we are trying to do today here. We all know that if we want to create a single, we want to create line, we need to use a line function, right? There are different parameters that this line function takes. For instance, like 4 arguments, right? So it needs X and Y position of the first point, and then X and Y position for the second point, right? But what if instead of creating a single line, I need to fill this entire canvas with a lot of lines which are perhaps equidistant or something? So in that case, if I start doing this, for instance, like if we start using hard-coded numbers, 0, x1, y1, right? And x2 and y2, we might not see this one because it's just at the end. That might not be very helpful. So for instance, let's see if I have x1 here, y1 here, x2 and y2. Now we'll see our first line appearing. And then we have here another one. Let's do x2, x1, y1, x2, and y2. So we see our second line appearing. Now, this is a very inefficient way of creating and filling your entire canvas with these many lines, right? So what if we resize our window and then we need to add so many more? What if we want to increase or decrease the size between all of these lines? So that's not really helpful for us. And what are the things that we can do, or what are the steps that we can take to kind of make it a bit more dynamic and easier for us so that the computer is doing all the calculations and not us? So let me just comment this out for now. Okay, so one thing is that we can definitely use variables as parameters for line. And those are going to be super helpful. Why? Because the whole purpose of variables is to keep the values inside it keep changing, right? So it is not a static value. It is something that can keep on changing over a period of time. So that's one thing that's helpful. What about the other thing? If we want to create so many of those things together, remember we had previously learned our for loops, right? And let me just put this here. So what is the kind of structure that our for loop has, right? It has 3 important ingredients. So first one is the counter, right? Where we define and where we declare our variable and assign it a value, right? And that's where the counter starts and begins. And then we have another thing, which is condition, that needs to be met for in order for it to perform something, or whatever the code of instructions or set of instructions that we have put inside the curly bracket. And then the other thing is the change, right? How it will change over a period of time. So it could be either an increment or a decrement. So in this case, let me just put it as an increment, because we will keep on adding lines, right? So that is a structure that we know of. So let's try to create our for loop here. And since we want to create a lot of lines, I'm just going to put this inside. We already know that, right? So again, here what I am trying to do is I am trying to create vertical lines on entire canvas, okay? Just because it would help us know what we exactly are doing. All right, so going back to our for loop, let's do a quick one. We know the structure. So starting by declaring a variable I. Okay, so I is a standard way of writing or a variable here or naming the variable here. There is a reason behind it, which we will cover when we talk about arrays. But for now, just start using this because it's a standard practice. And also it's just one letter, so it's easier to write. And then let's put our condition here. So why we are putting I is less than width? Because we want the entire canvas's width to be filled with a lot of lines, right? So that's our condition that needs to be met. And since if you notice here that we were going 10 pixels apart for each of the lines which were being created, so let's just keep that as our increment point. Okay, so here we are saying make sure that, okay, there is a variable I which starts at 0. As long as it's less than the width, keep on adding 10 pixels to each of them, right? And it will reassign the value. So we can use this variable I to sort of add in some of the variables here. And what we can do here is, first of all, we need to declare that x1 be something. In this case, we will take x1 as the I variable. Why? Because if you noticed in this one, we were changing the value of x1, right? So that will help us make it more dynamic, because we will use I, which is a variable that will keep on changing. And then we will use let y1 be 0. If you noticed here, we were keeping it 0 because each of the starting point for y was at 0, right? Because we were going vertically. So all of those are starting at 0 point as the y1. Then we will create another one, let x2 be the same as x1, right? In this case, it's the same, so I can literally call it I again. And then you can either keep it I or you can make it x1, so that's the same thing. So whatever the value of x1 is going to be, that is going to be the same for for x2. And then let y2 be equals to height. So if you notice, because we were keeping all of those as the same, right? Because they were ending right at the edge of the canvas here vertically. So now if you notice, let me reformat it. Okay, so now if you notice, all of these lines, no matter how big I make my screen or how small, or maybe I can just do this, it keeps on adding. Why? Because the condition is set to be as long as it's less than the width. So that's what it is working with. I don't need to worry about it. It will recalculate things for us. You can make it totally 5 pixels apart. So now it's just more dense. You can keep it 2. And now it's just too much that you can't see. You can make it 20. And they're much more wider. You can make it 100. So you don't need to do any calculation. This is doing everything for you. The number of lines appearing is totally dependent on the width, and you don't have to do any kind of calculation. And you just, that's one way of doing it. So that makes our lives much more easy by using the for loop. Okay, so that's one thing. But what if, think about it, what if right now it's covering the entire width of the canvas and also the entire length of the canvas? What if we want to have some sort of control, right? Maybe we want these many lines to appear, but maybe we don't want it to be appearing on the entire canvas, and maybe there's a certain portion of canvas where we can try and control it. So remember, if we want to have a bit more control like that, and if we want to use values from one range, and we can map them on another range, right, using the map function. So that's where this could come in handy. So in this case, what we can do is we can map the value of I, and we can set up an output minimum and maximum value, right? So we can define those kind of range. So maybe if I use, instead of this, I use the map function. And here I say, okay, take I as your input, where we know that the minimum value here is 0 that we want you to, work with, and the maximum value is width. Maybe make it 100 pixels away from the left side of the canvas, and maybe 100 pixels inside from the maximum width of the canvas. So if we try to do that, maybe we can, easily set our output minimum value starting at 100, and the maximum is width minus 100. So now we've kind of added some sort of like padding on both sides here, right? So it's not really doing anything. It's just that it's confined between these two starting and ending points, right? So that's one. But what if we want to add that kind of padding on the upper and the lower side as well? So, just like creating some sort of like a frame structure. We can do that by making some sort of changes to our y values as well. So maybe instead of making it 0, we start at 100 points. So now you can see there is some value added. And what are we going to do for y2? Here we can make it height minus 100. All right, so now you can see that we have sort of created a consistent sort of frame around, and we only needed to map our x1 and x2, but we didn't need to write twice. We just made sure that whatever, because it's a vertical line, so the x position is the same for each line for x1 and for x2. So now this way we are able to get our vertical lines. But what if, another question, what if we want to not create vertical lines, but maybe we want to create some sort of like horizontal lines where we can do everything starting, instead of the width, we can do it with height. But what if we want to create some sort of like diagonal pattern here? So if let's say we start from the same point, but we don't want to end it here, we want it to end here, right? So they start going like this. In that case, we already know that our x1 and y1 would be the same. So imagine if we are starting from the same point. So we don't need to touch our x1 and y1 in this case, but we need to play around definitely with our x2 and y2. So what can we do for that? So for now, what I will do here is, let me just comment it out so that we know where we are sort of playing with. Yeah, let's just, or maybe let me make changes to this one, that's fine. Okay, so here we need to change our value. Instead of the same, the x2 value now cannot be the same as x1, right? Because if we don't want it to make it vertical, that means that it needs to have some sort of change. And if we want to keep this kind of padding and cushioning here, then maybe we can change the x2 value as 100. All right, so that's kind of starting at this point. And now we need to map our y2 values, right? Because they are kind of like merged at the same point. So maybe we can change this. And we can say, okay, you can map whatever the value that you are getting for I, map it all the way from 0 to height, which is the maximum. And the minimum output here is 100, and the same as height minus 100. So now you can see that our values have changed. So all the starting point x1 and y1 stays the same, right? Because these are the starting points for either our vertical or horizontal line, vertical or diagonal lines. But for diagonal lines, we needed to make changes where the x2 and y2 positions were. So we mapped our y2 values, and since we just needed the sort of same starting point, which was 100 pixels from the starting point of the width, so we just gave it a hard-coded number for now, but we mapped our I value to the height. So that is a good practice for us to do that. I can leave all of these comments. Just make sure if there's some sort of repetition, we cannot declare x1. We cannot redeclare variables in our code. So if we wanted to keep the previous code for vertical lines, I can leave that for you to revisit the code, and you can have a look at it. Just make sure that you comment one thing out if you want to see the vertical lines or the diagonal lines. Okay, so that is one thing. So we've been playing around with lines, but what if we wanted to work with some kind of rectangles? So let's try and see what we can do with rectangles, and maybe also some sort of mapped rectangles. Okay, we are going to also play around with some sort of mapping here. So let's say, what are the things that we need for rectangle? We know that it takes up x, y, width, and height. So I've just put them as variables here so that we know what we need to create. And let's create like in a for loop. We know the structure here. So before we begin, I'm just going to move this inside because that's where we need it. And we can start creating our variables here. Also remember that the I variable which we are creating in the loop is a local variable which is inside here, so you don't have to worry about it. It's not a global variable. And here we can say I is less than 30, just an arbitrary number, and we want to increase it by 1 each time. I'm going to comment this out for now so that we don't have any sort of trouble and we have a clear screen. Okay, so if we want to create this kind of thing, we need to now declare some sort of variables inside here as well. So let x be something, and let y be something, let width be something, and let height be something as well. Okay, so all right, so we will make we will create different x positions. Again, going back to our starting point, we will use I and map it. How are we going to do that? Let's try to map our I, and we can start again with 0 and width. Oh, not width here. In this case, it's going to be 30. Why? Because our condition is set to 30, right? And then we can start making it a bit more central. I'm using the same as the one before, but these are all arbitrary as well. So what if you don't want it to be width minus 100, right? What if you make it 10% of the width? You can totally do all of those things. That's something that you are setting up as your output minimum and maximum value, and that's totally fine. Even in this one, you're creating the range as well for yourself. All right, and let's try to make it in the center. So we know how we can centralize it in terms of height, and make it as 10. Let's see what that happens. It's going to be a square. Okay, so this is quite static. And if you know that the starting point is basically on the top left corner for each rectangle, maybe a good way for us to do that here is to create a rect mode, and let's make it at the center. So now these are all at the center. So now we've created so many of these rectangles, but imagine if instead of making it 30, we want to make it as 100. But then the range is set to 30. So now that you can see it's kind of a little bit out. So I need to make changes here as well. And now it's like that. So this is not a very efficient way of doing it. Maybe what we can do is we can create another variable and call it like number. So this is just like saying we can use this variable inside here. And then we don't have to worry about changing it all this time. So I can make it either 100, I can make it either 10, I can make it here 50. I don't need to worry about and keep changing it. One thing that I do want to mention here is that because the first time the value that has been assigned to I is 0, so that's the first value that it is taking. A good practice for us to do is that this condition will not be met when it touches that number. So in this case, if it's 50, when I turns 50, this loop will stop meeting the condition, right? Why? Because we have said that it needs to be less than whatever the number is. So as long as it's less than 50, that means at 49, it's going to perform till then. So a good idea for us to do that is here, make sure num -1, and that is going to be helpful for us. All right, so here we can do that. Maybe instead of keeping it as 100, we can add another function and try to make it a bit more variable and see how that turns out to be. Maybe we can set up another range here. So instead of doing this, we can say, okay, the height needs to be as small as 50, but it needs to be as high as 300. Okay, so if you notice, I'm having all of these things happening at the same time. And why are they acting up like this? Is because we are doing everything in the draw function. So if you know that the draw function executes things continuously, and you remember that we are just seeing frames being changed each time. So that's what we are seeing with in terms of the speed. So a good way to do that, and if you just want to see it once, we can stop that loop of the draw function by calling this function called noLoop. What we are just saying is that we are really literally pausing the loop that is happening in the draw function, right? So it's kind of frozen at this frame. If you go here to our reference page, you can always see there is, again, a noLoop method and a loop method. Just remember that this loop that we are talking about here is different from the for and the while loops that we are talking about. This loop that you see here is basically in response to the noLoop. So if we want, because right now we have asked it not to loop, right? That's what we have asked our draw function. So if we want to resume this loop to happen again, then this is where this loop comes in, okay? Just wanted to, let you guys know that this is a different sort of loop than the one that we are talking about in terms of for and while. And also, you can literally, resize your window and see how that kind of affects, but it is readjusting. And right now we see the movement because remember, whenever we call this event window resize, it's at least doing it once, right? Even though we've called the noLoop. So that's why we're seeing all the adjustment happening at the same time. Okay, so this is it. I hope you enjoy working with the for loop and the map functions. Yeah, just play around with it and see where else you can map, use these functions and try and combine different things that we have learned so far and see how that goes. I'll see you in the next lesson.